Hello everyone, this is Captain Gilbert Lee. I'm speaking from Taipei, Taiwan. Welcome to our discussion of the dynamic radar presentation. This is the idea of mine to developing the 21st century's radar picture to really help the duty office in his lookout duty and supporting his collision avoidance decisions when he needs. Okay, yesterday we started talking about the small vessels target, even the big vessels target. When coming to the close range, suddenly lost its echo because it's merged with the sea cluster. Maybe we can understand, but we cannot accept this kind of substandard radar presentation carried out from the 1970 or 60. So, when the target is clear, more than 3 nautical miles away, we should assign one target shape for this echo, and the computer need to find out the algorithm to calculate to properly present the target's speed and course change, even if in very close range. We don't care the radar's echo sent intermediate. That means he sent a long wave for maybe 100 microseconds and another 10 microseconds for the short wave to detect the big target in close range. Anyway, they must be worked out one way to overcome this major deficiency, because in this close range it's life or death. This is the lesson we must take from the loss of 32 people within 3 minutes after collision. Okay, let's look up this picture. Is 15:03, half hours since last radar picture. In here, we can see on-ship head crossing a recons, which is a mark of the traffic separation scheme. In this light buoy, all vessels coming in 4 directions, north, south, west, east. And this mark we can see there were 4 vessels going to eastbound as on-ship, but on-ship position is clearly above the separation buoy. North of the buoy is not the correct position, so on-ship trying to go back to south. But there were 2 small vessels coming from south. One is a tugboat with his tow, another may be a small cargo vessel. So in this time 15:03 hours, there was one collision spot with the eastbound vessel. This spot is about nautical miles away, and this vessel is about 3 nautical miles away. So if we calculate from on-ship's speed vector 6 minutes, this collision spot may be 3 times longer, means 20 minutes later we will have the collision with this overtaken vessel ahead. So we're showing the collision spot. Actually, this spot is not very concerned of us, because the timing is 20 minutes later. The actual Problem is the vessel coming from south, which was a tugboat and his tow and another small northbound vessel. Surely on this picture there were other vessels coming from north going southbound, and also some vessels already passing the separation point going to north, but there were no collision risk with on ship, so we should keep the picture as simple as possible. Only concentrate on the vessel which might be cause the problem with on ship after a few minutes later. We can see from last picture 15:03 to now 15:06, 3 minutes time. The duty office still have not acquired the northbound vessel coming from south, which is about 125 degrees on ship's starboard bow. So what we're saying is, based on this idea, so we asking the manufacturer to provide the virtual speed vector, which with the towing tugboat vessel right now showing us red speed vector, and the calculate our assumed collision spot as a red spot, because on ship and this tug vessel were arriving the collision point about the same time, so the collision is unavoidable if nothing to do to avoid the collision. And for another vessel going northbound, there's a green speed vector and the green collision spot. The radar picture should automatically provide the presentation to help this careless duty office to do its lookout duty. So we didn't acquire these two targets from the ARPA. The radar system should have this dynamic presentation. According to the data of these two targets past the 3 minutes trail, which we see as the shadow after the echo, or the tail of these two targets. This tail length is 3 minutes. The radar should be able to calculate his direction and the length to create a virtual speed vector based on the radar observation. Original radar plotting is all based on the past position, speed, and the course. So there's nothing wrong about if we use this vessel 3 minutes tail or his trail to create a virtual speed vector for our decision making in the radar pictures presentation. Okay, let's explain why these two targets speed vector. One is in red, dangerous color, another in green, safe color. Because the red spot, which was the collision point with the tugboat, is about 9 minutes run for on ship, and it's about the same time for the tug vessel to arriving this collision spot. That means the collision is very likely to happen. almost for sure. So this collision spot is marked with red. And another northbound vessel, even if its speed is fast because the green length is longer than the red one. Why his spot is green? Because for on-ship to arriving the green spot need about 2 times of this 6-minute run. That's 12 minutes. And for this vessel northbound going 000, she only needs 6 minutes to arrive. So when we arriving this green spot, this vessel already passed 6 minutes before. So this speed vector is safe with green spot. And because of our presentation is for the supporting of decision or identify the target, so we need mark the target's bearing on the azimuth circle. This is what we see in pink spot on the azimuth, which right now is 126 degrees. And the next picture is this 6 minutes picture, which only gives us the idea what it's like at the real sea, real life of the seaman. We can see this tugboat and the northbound vessel still not in the floating situation. Okay, this is the presentation on the axis, which there were AIS signal input. So we can see the tugboat's light shape on the target. This is good because it's helping us understand the situation. So this vessel's shape should carry out to the radar screen. We don't need to look at two screens and identify which is which. So this is the presentation of overlapping the axis and the radar picture. We can see if the radar can provide some traffic separation line on the radar picture, it's more easily for the duty office to identify which vessel was outside the traffic separation scheme, and maybe it is an anchored vessel. And it happened as the target vessel in close range is the recon. Recon is used for outside the 3 nautical miles range. Once in the close range, the recon loses its target and its echo. So the recon should also assign a target shape as a recon to it. This is all accomplishable because on-ship have GPS input and the axis have GPS input, so it's easy to identify the echo on the radar screen. Only is the manufacturer have to merge these two equipments property to make proper presentation for the duty office use. We can see right now the radar have acquired the target of these two crossing vessels at about maybe 2 nautical mile distance. So why is the duty office too lazy? No, it is because of the duty office have distracted by other targets' movement. So that's why he didn't have the time to acquire these two targets. And what kind of assistance we need, we are talking about in next talk. Thanks for joining with us. Bye bye.